We are asked how much energy does the pump need to supply to 1 kilogram of water to pump it up to the water tank here. Okay, so we have the mass, which is 1 kg, and we want to, the water is initially at this height, at the reservoir height. So if you want to pump it up to the tank, right, it's just a height difference of 10 meter. So you want to give it an extra height of 10 meter, that means our height difference will be 10 meter. So the amount of energy required, it will be the same as the gravitational potential energy that the water gains. So that will be gravitational potential energy is equal to mgh, that will be 1 kg times 10 times 10. So it will be 100 joules. Answer B. Okay, in this question, we are given the energy and we are given the time in hours. So we want to find out what is the average power output in watts. So power is equal to energy divided by time. So our energy, we have 432,000,000 joules, and we divide by the time, which is 24 hours. You have to change it to seconds, so you have to times 60 times 60, and the answer that we get here, it will be 5,000 watt. Answer A. When a beaker of water is heated at the bottom, the sequence to form a convection current should be like this. Okay, first of all, the water at the bottom becomes warmer. So this is number 1. Then after that, when it becomes warmer, the water will expand. And when the water expands, the volume increase and the density, which is equal to the mass over volume, will decrease. So this is number 3. And when it is less dense, right, the less dense water will rise, and the cold water, which is denser, it will move in to replace it. Hence, it will create a convection current. Okay, so the sequence should go 1, 4, 2, 3. So the answer is C. Boiling point is the temperature at which the liquid will change to a gas without a change in temperature. So it is not a place, it is a temperature. So we are left with C and D. So option C says that it's the temperature at which it begins to evaporate. Evaporation need not take place at boiling point only. In fact, it can take place at any temperature. So this is wrong. And let us recall boiling. During boiling, there is a change of state from liquid to gas at the constant temperature, which is the boiling point. So at that temperature, right, the substance can exist as both liquid and gaseous state until the whole boiling process is completed. Answer D. Okay, we have 2 diagrams here, so let's go through what does P, Q, R, S represent. Okay, P represents the distance of one complete wave, so P is the wavelength. And Q is the distance from the equilibrium position to the peak. So this is the amplitude. Okay, for R, this line is a line that joins all the crests in the wave together. So this is the wavefront. And for S is the distance between 2 successive crests. So this is the wavelength. Okay, now let's look at the option. Okay, for wavelength, we know that P represents the wavelength. So either option A and B are correct. For the wavefront, it should be R. So the answer is A.